заключним спікером на сьогодні буде наш гість з Польщі Jarosław Porwoł з компанії Future Processing. Jarosław is the first time in Ukraine, so let's support him.
Thank you. Hello everyone. Nice to see you all. Nice to be in Ukraine. I haven't seen much of it yet. I definitely will see some beer-related parts tonight, as my colleagues have promised me. Today I'll talk a little bit about me, because why not? I changed a little bit, so I grew up beers. It's not epic one, but it is something. I've been working as a developer since 2009, so that's about 10 years now. I started with Future Processing, then I moved on. Then I decided I liked Future Processing better than the other companies, so I moved back. I mostly do C#, ASP.NET, a little bit of front-end development, not too much. I'm not super familiar with all the new frameworks and everything. This is really complicated now. But in this presentation, I will talk about front-end, because why not? I'm the presenter here and you can't stop me. So what I will talk about is the most common performance problems I've seen in the applications. Mostly in the application I wrote with my team, and we made all those mistakes. So all that I will be talking about today is coming from my experience from the beginning of the year, when the client came in and said, well, now we've released this application to thousands of users and now it's starting to get a bit slow. So could you make something about it, make it a bit faster? So we started solving all those problems. We started from the front end because, well, I don't know anything about front end, so that's probably where the problems are, right? So slow front end. This is one of the most useful tools that you will find. This is Chrome developer tools, so all the developers here, or all the testers here, should be familiar with it. If you press F12 in pretty much any browser these days, it will show some kind of similar window with all those different tabs and everything. And this is the performance tab. Ooh, I can do the pointer thing. So this is the performance tab. And the first issue that we had is related to this one. So if you see, this is the actual our application. So I'm kind of ashamed to show you this, but then again, well, what will I do if not learn from it? So this is how long it took us to render the page. So the time here starts at around, I don't know, 13 seconds, and it ends at 16.5 seconds. So that's the first call. It takes 3 seconds to just render the page. It's not loading the page. It's not server-side. It's just rendering the page on the screen, so people will see content of the page and be able to click on it. Well, it's not super bad. It's 3 seconds, so you can live with that, right? If you have thousands of users, well, fortunately, those problems don't scale with users, so everyone has their own browser, and all the problems are on their own, but well, 3 seconds are not that good as well, right? So if we can do something about it. So here in the bottom, you can see what takes so much of our time. So it even says it took till 17.3 seconds, right? So even more, almost 4 seconds. So scripting. Oh my God, the scripting took so long. It's a second and a half of just passing the scripts and running the basic scripts that run just after you refresh and show the page. It's so freaking long. And it happens every single time people click on any link and move to another page. Because we don't do Angular or React or whatever. We are old school and we just do knockout. Anyone remembers what knockout is? Right, so there's at least one crazy person in the room besides me. We decided on Knockout because we started this project quite a few years ago, and then Knockout still was a thing. Now it's not, so don't use Knockout, that's the first lesson. We also use Telerik Kendo. I guess everyone, yeah, thank you. Everyone been using Kendo or whatever other control package you will get for your super business enterprise applications. The big part of it is, I don't know which part, probably not this one, maybe this one, is passing Kendo scripts. Because we, as a genius front-end developers, just included Kendo all.js to the page, and it it prepares every single control that you might ever use from Kendo, even though we didn't use like, I don't know, half of it, maybe even more. Still, again, every time someone renders a page, we did it. Yeah, so that's about 3 seconds. So like I said, it's probably even more because the browser says so, or can't do math apparently. Evaluate script. Oh yeah, so this is 400 milliseconds of just doing Kendo. Like I said, freaking long. Don't do that. You can do better. 200 milliseconds is just of processing JavaScript attached to onload. So what it does is basically just sets a few classes and then maybe hides a bit some parts of the page depending on the screen size. Every time we load the page, we run those scripts and it takes really long time. And again, some processing stuff, XHR ready, so we just loaded some additional data and just trying to display it. It's almost half a second, still super slow. So, in case of Kendo, we decided to just stop using Kendo all, because that's a stupid idea, don't do that. With Kendo, and I believe with all the other big control manufacturers in the world, you can do design package of all the controls that you actually use. Well, I don't know whether you want to just do it separately for every page, possibly not, maybe you do, I don't know. You probably don't want to use all of those. We're using at most 50% of those controls, so we could just remove half of the JavaScript, reduce the load size, reduce the passing time, because the browsers pass JavaScript every time, even if the file haven't changed. So that's one thing the browsers can do better maybe in the future. I don't know, I'm not super good at front-end, so maybe they can't. So limit number of processing done on load, so that slows down the page most of the time. And most of the time it's not needed, but maybe you can do it a bit later and react on some evil. I don't know. Probably not a good place to do 600 or 1 second worth of work, right? And bundling the scripts. So I included that at the bottom because I assume everybody does that. If you don't, just read what bundling is, read what Webpack is on Browserify if you're an older project. Learn how to bundle scripts in ASP.NET MVC, but I guess in ASP.NET MVC everybody does that because that's a standard package that you get, right? Don't be fooled by checking the app in debug mode. So if you have your app compiled in debug mode and have debug flag set in web config file, it will not bundle. The ASP.NET MVC will not bundle those files all to one package. If you switch to release mode and if you change the debug flag in web config to true, it will. So not everybody's aware of that. So okay. Caching. Next thing. So like I said, we don't use all those fancy React, new Angular or whatever. This is for the new kids on the block. I'm old and I don't know how to use React correctly anymore. Like I was talking on the break, I learned how to use Angular and then 5 months later everything about Angular changed, so I didn't bother to learn it again because I didn't need to yet. I will learn it, just not now. So we are doing everything by ourselves. So we are loading scripts using jQuery. We just push a GET request, get HTML and response, and append it to the DOM model. Right? That's easy enough. Everybody can do that. Turns out it doesn't work as easy, as good as you would hope. So we noticed that a bunch of the requests are done again and again and again. And all those JavaScript files haven't changed, and those should be cached on the browser side, right? Because why ask again and again for the same file? It didn't happen for some reason. Turns out jQuery, when we did jQuery get and attached the element to the DOM model, jQuery to every JavaScript request that came in from the attached model, they added this small little parameter. It's underscore parameter with current timestamp as a value. So 17 whatever, I don't know what the current timestamp is. It was adding that. It's effectively a cache busting mechanism, so in case something changes, load the new version. It probably didn't change. We had to fix that. Simple enough, it's 3-4 lines of code. Finding that on Stack Overflow took me, I don't know, half a day of looking around and checking and figuring out what doesn't work, because it's not very common for people to look at those mistakes, because everybody now uses React or Angular, and it just works. So maybe the lesson from that is just use Angular or use React, and don't be stupid as me and use Knockout and do everything by hand. But if you need to, please remember there is something called Ajax pre-filter that will run before Ajax request, and you kind of can customize it. You can probably use it for all kinds of different purposes if you want to. This is what we did. We just set cache to true, and that automatically turned off the parameter. For everybody who wants to say, well, you can say this option cache to true before all the requests, pretty much. Yeah, but jQuery overrides it in case you attach or append HTML to the DOM element. Useful tips. Lots of people don't know this. In F12, in the developer tools window, on the bottom, if you press escape, it shows in height in Chrome. It shows in height, and sometimes you don't know why, because it's just because you press the escape button. There's this console thing, but if you press on those three menu icon, this menu icon, burger icon, just very slim burger, I guess. If you press, you get a bunch of options that you can check. One of those options is rendering, and this is super useful if you have an application that should be fast, but for some reason seems sluggish and seems to jump around and just doesn't work correctly. There's a bunch of options that you can use. You can use FPS meter. It will show you, like when you're playing a game and you use fraps or whatever to record the screen and just see how good this new GeForce is performing. You can do the same in the browser. That's probably not as much rendering going on as with new whatever game is popular now. You can use pane flashing, so it will show you every time some piece on the page is being re-rendered, it will flash green and you will notice it. So you will notice in case for some reason you are constantly refreshing all the elements of the page. That's super useful. Scroll performing issues. So sometimes page seems to behave correctly, but when someone scrolls down, it seems sluggish. It's probably because you've attached a bunch of events to on scroll. But this will highlight those elements and will help you test it. There are a bunch of other options that you should have a look at and give it a try. Network tab, everybody's familiar. Who doesn't know what network tab can do? Everybody does, so I'll just probably skip that because I'm probably running out of time already and I just started. There's this clever tab, Audit, where you can, it's called Lighthouse by some people because there is lighthouse picture in here. I don't know what's the relationship between all those things. You can, it's in Chrome. I don't think the Firefox has it, but it's in Chrome, and it will refresh your page and will gather all the statistics and will figure out why your page is slow on load, probably. You can also throttle the connection and everything. You can change if it's mobile on desktop and change a bunch of other options. That's really useful. Even if you have fast app, you might think you have fast app, but Chrome might beg to disagree, right? Next step, moving on to backend, because that's all my knowledge about frontend apparently. We do love data. We love thinking about processing large quantities of data, but we suck at it. Everybody does, in every single project I've seen. Mostly because we don't test with live data, we don't test with actual volume of data that people will be using. We just have, I don't know, 10,000 rows in database and we feel happy because it's so fast and all the calculations are super fast and everything works. Then the clients get it, they put 10 million rows of data in database and suddenly it starts to get slow. So, quick lesson, do use live data if you can. Sometimes clients don't mind if you use the live data, of course, anonymized and everything for testing. Do that then. If they mind, try to replicate the data structure, try to replicate the amount of data and probably multiply it because the data volume will grow over time. And test with that, because only then you will get some kind of feeling of actual live performance on your developer machine. Right? Test your query performance. Most of the problems in our application came down to some queries performing bad. They were performing superbly fast on our developer machines with our set of test data, which was orders of magnitude lower, smaller than the actual data. So even if you think that, well, this query is good enough, or I write the best queries, right? Probably don't trust yourself, probably test those queries. It's easy to get it right if you just get one row from the database and just show it on the screen. There, you probably can't screw it up. But if you need to calculate something or get some, I don't know, average data or whatever data relationship that you have between those, and you need to follow those relationships somehow, you probably can screw it up, and you probably will, as we will learn from my mistakes. N+1 queries. Who doesn't know what N+1 query is? Everybody does, so that's great. We know too, we know now, and we also did those mistakes, and we did N+1 queries by mistake. Because it's easy to think that, well, my queries don't have this problem. Well, and you probably are right. If you disable lazy loading completely, then you don't have this problem. If you don't, you might be surprised how easy it is to sometimes get N+1 queries in your application. Because, well, this query kind of looks super simple and it kind of looks okay until you see this part where it calls to some other subcategory products count and it generates N+1 query. It's not easy to see it from the code, right? The code looks perfectly fine. It's, I don't know, 5-10 lines of code, including all the parentheses, brackets, and everything. So, well, it can't be hard to get it right? It can, because this is not production code. This is just some fake code that I wrote. Because I can't show you my production code. I can't show you my actual mistakes because of NDAs and everything. But the actual production code has layers, as you probably know, and as you can probably see on my shirt if you look closely and you say hi after the talk. The layers hide all those problems sometimes. So the query is simple enough. You just get the record from the database and pass it on. And then someone who doesn't know what the data actually is, an entity framework lets you say, well, let's call this subcategory products. Yeah, that's easy enough. Entity framework will handle it until it won't. Well, it will, but it will make your application super, super slow. So that's how the query looks in the SQL profiler. If someone is not familiar with SQL profiler and is using SQL Server or whatever other server, because there are profilers for other ones as well, you should get familiar and you should start using it and not just know about it, because that's easy enough. There's one query, then there's another one, and there's another one, and the list goes on. And I don't know if there is a good way to make sure that there is no N+1 queries in the system. But if you look at those queries coming from profiler for a single action, you will notice that those queries are pretty much the same, they just differ in this value. And if you have loads of queries like that. And if you start looking at the profile and just see it scrolling, it's scrolling, it's scrolling, then that's probably where the n+1 query is. And you definitely need to fix that. Again, simple case are simple. It's easy to notice in small code. But if you start writing production code, or if you get legacy code, or if you are, well, I don't know, you like using different libraries and stuff, but using automapper to just map entities to DTOs that you want to transfer to the UI, right? So it's super easy for someone to add mapping for additional column because you just want to get the number of those subcategories or products in those categories. It's so easy to write this in automapper mapping definition, and then you end up with n+1 query that you even don't see in a code because it's automapper doing it. Directly binding entities to views in CS/HTML, if anybody's still doing that, probably not. It can cause calls. Reflection, all those layers of complexity that you add and add over time, it will make it super hard to notice. We didn't know we had those n+1 queries. We paid attention, in some places at least, to do not make those mistakes, and then we did them anyway, right? Disable lazy loading if you can. That's super easy to do in Entity Framework, I guess, in a Hibernate or whatever ORM you are using. It's easy as well. Do that. If it's not an option for you, it wasn't for us because that was kind of legacy code and kind of we didn't want to. It wasn't an option. Measure queries performance. Check your queries with SQL profiler, like I said. And be aware of ego loading. There's an include option. Everybody probably knows that, so I'll just include this. Sometimes good query is not enough. So sometimes you want to filter by name, description, or external system ID. That was the case for us. So there's a quick search functionality on the page where people just write whatever gibberish they want, and it shows them the thing they are looking for, wherever the data is. Well, as long as it's in one of those places. It's super fast if you have small database. So tens of thousands of records, no problem. We're gonna do it in less than 100 milliseconds probably. So that's the amount of time that users will never notice, right? But if we get hundreds of thousands or millions of records, those searches start to take time, more and more time. So indexes. It's not a bird, it's not a plane, it's an index. And this is a superhero cap because I'm so awesome with PowerPoint presentation that I had to do it. So in short, what indexes do, everybody knows probably. Who doesn't know what indexes do? Everybody does, right? So if you have those queries that happen all the time and they follow the same set of filters or get the same set of data, make sure that you don't need an index, or make sure that you have the index that you need. Because sometimes you don't. Sometimes the queries don't happen too often, and the indexes carry their own cost, right? So every time you insert the row to the database or update the row, the index might change and might need to be recalculated. That takes time. If you had thousands or tens of thousands of users, those values add up, right? But if you need this index, make sure you have it, right? There are two types of indexes. There's clustered index that you can have only one of. This is the actual place where the data lives. There's no table on the disk. It's just an index with all the data. But there is also I'm the table, so the clustered index. I forgot how funny I was when I was making this presentation, so I forgot about the slide. So there are also non-clustered index. Those are the indexes that you build upon existing data that speed up your searches. The trick is to have the filter in the order those columns are defined, because sometimes if you change the way you filter data, it will change the way the SQL Server can use the index, or sometimes it will make it not be able to use the index or whatever. A bunch of rules. I'm no expert in this area, but it may have an impact. So if you change your query, make sure that the index is still applied correctly, right? So have a look at some execution plans. If your query is slow, the execution plans in SQL Server will suggest you sometimes that, well, maybe you want to create an index in here just in case, right? Tip that some people don't know, indexes don't only have to have data that you filter on, they can also have additional columns. So there's a benefit to that, that if you only query the values from the index, you will never have to access the actual database, table file or whatever on the disk. You will get all the data you need from the query, from the index you are using to speed up your query. That may make a difference. English is hard. Examples. So it's easy enough to create an index. So there's create non-clustered index and quick search, blah blah blah. On record, time, delete date, blah blah blah. Include timestamp and description. So we never want to filter on timestamp or description, but we want to show those values in the search results. So this way we include those in the index, and this index is all the data we need. We never have to access anything else. And the databases are super smart about indexes. They will make sure that accessing this index is really fast. Did it help? In live case scenario, from 6 seconds down to 400 milliseconds with live data, large amounts of data. More than that, if we didn't have the index, this 6 seconds would quickly become 8 seconds, 10 seconds. Those 400 milliseconds will probably stay at this level for a long time, because indexes, complexity of the query for index will not grow as fast because it's completely different structure, probably some kind of trio behind the scenes, right? Slow queries. So if you have lots of data, and if you have a complex query, you might end up with slow query that you can't do index for. Right? Because sometimes the query is so complex and you have so many columns that you need to filter on and ask for. Creating an index is not necessarily a feasible option, right? But this will happen, right? So query is mostly about joining the tables. So we need to gather the data from 10, 15 different tables. We need to generate big reports for the business managers or whatever. This is not something that's happening every day or maybe every hour. Maybe it does happen every day, but it will happen, and those people want to have it fast because they are business managers. They pay your bills in the end. So if anything, the application is supposed to be fast, it's probably this one, because this is what the money people will see. But indexes might not be the way to go, right? So what will help? A good query. So, yeah, well, that's easy to say. Yeah, silly devs who write bad queries. I write good queries all the time. I think you do. I think I do. Until I write a perfectly good, fast query, and then the business manager comes in and says, well, I would like to change this bit. And then he comes again and says, oh, I would like to change this bit. Then another business manager comes in and she says, oh, I want something a bit more different. And you start change this query and change it and change it. And it looks no more like the original query you started with. And it's slow. Right? So what we did, we rewrote it. So sometimes it's just a nuclear option. Just say it, well, I give up, this query is stupid, I'll write it again. That's exactly what I did. We had this huge query. I had to scroll my screen twice to see all of it. Well, it's what the business needed. Yeah, I know it sounds stupid, but it's what the business needed. And it just changed so much that it became unbearably slow. Right? So, in general, if someone tells you just rewrite it, yeah, especially if it comes down to the whole application, so we're gonna throw it all away. We're gonna write it from scratch in 3 months, and it will be better. It won't. 99% of the time, it won't be better. In this case, it will. So the initial query took 20 seconds. The new query, returning the same data, does it under 2 seconds. So this is still complex query. It processes lots of data, and this is some kind of reporting query for the business, right? So it doesn't matter if it takes 2 seconds, it just can't take 20 seconds, right? So also the new query is 13 lines shorter, which is also a good thing because everybody loves when they do push on Git and they see that merge request is shorter than the original code. There's always a bonus point, right? So no tricks, nothing fancy, nothing extremely big. Well, sometimes just look at the data, at the query you're writing, at the code, because it doesn't have to be queried. Sometimes it's just the code that you're changing. Sometimes it's just the nuclear option. But just make sure that it's really this case. It's just not you just trying to use a new framework or just not liking the previous developer or whatever. Right? So nuclear option, we sometimes have to slay the monster. I wanted to use Witcher because I like the game, I like the books, right? But also because Ukraine has its own Witcher. I don't know how many of you knew about that. How many of you knew about the Witcher game and Witcher books? Right, so quite a few people, right? There's this guy, it's a Russian guy, so I don't know how popular that gets him in Ukraine, probably not very much. But he wrote something about the big Kiev Witcher, future cyberpunk stuff and everything. I've read like 4 stories a few years ago. They were quite nice, and there's a big Kiev, right? So that's a good thing when you go to Ukraine, right? I guess. Let's get back to business. One big problem is security. In our system, we have really complex security rules, right? So every user can have different security permissions. Every single record in the system can have different security logic attached to it, all because the money, yeah? So some people can see things, some people can't see things, and just like that. Every time every user accesses any kind of data, we need to run the security. We need to make sure that this user can see this data, can do this operation. Every single time, every action in the system is about data, so that happens a lot, right? So the initial query that we got from the legacy system was working fine, but it was working fine until you put tens of thousands of records in the system. Then it started to get sluggish, and by sluggish I mean it started to take 5 seconds to check security for some records, right? That's not perfect. So we changed it a bit. We updated it. We started using different things. We rewrote the query a little bit, and it was one complex query again. We got some better results. And then people came in, and instead of 100,000, they threw 1 million records on us, and it started to get sluggish again. So with 200,000 records, we had to check all 200,000 records to just show how many records are there on the search page and how many search results are there. Well, of course, on the search page, we just show 10, 20, or 50 records, because nobody wants to see a search page with 200,000 records. We're not that stupid. But if you want to show that there are 20 pages or 40 pages with records, you still need to check every single one to know how many pages are there. Well, one option is just don't show how many pages are there, just show the next button and previous button, and that solves it. Yes, if your business will allow it. They like the idea of knowing how many records are there. They like the idea of having all those page buttons that they could use to switch pages easily. So we couldn't do that. So we made the query faster. But the initial version, yeah, so like I said, and then it wasn't enough. So we did something different. So again, what I say, it's a view. What is a view with muscles? Again, because I'm super fond with PowerPoint. So there's a thing called indexed views, right? So I don't know how many of you are familiar with that. Maybe not too many, hopefully, because I'm just going deeper and deeper, hopefully getting something that some of you didn't know, so everybody learns something. There's a thing called index views, also known as materialized view, because that's how the Oracle calls it. Index view is the name that Microsoft uses, because who needs less complexity in the world? We can name the same thing twice and just worry about the consequences later. So it's a view, but every single view, if you create it, will get re-evaluated every time you use it, right? So a view is kind of like a, I don't know, a function call, whatever, that will get re-evaluated every time. Index view is kind of different because it has an index, which normal views don't have. So index is a structure that gets saved to the disk, right? So this way, the view structure, the data in the view, gets saved to the disk, and you can access it and get the results much, much faster, right? So yeah, again, whatever I said before, it makes queries cleaner and easier because you still use views. So you still save some of this complexity, you move it away to a different package, and that makes it easier. That's why we split the code in function calls and whatever. We just don't write 10,000 lines of code in one function call, right? We don't do that. Who would do something like that? Definitely not me. Well, not today at least. So it's persistent view. It doesn't have to run again. So what about my data? Well, every time the data changes, the indexes will get re-evaluated because they have to be up to date, right? So that will make your transactions go longer if you update the data. If you add new data, it may change the index structure. It will need to re-evaluate the index. But if you don't change the data too often, well, yeah, so if you do it often, it will hurt. But if you don't do it too often, it might be the solution you're looking for. In our case, we don't add those records all the time. It's not like people are saving tens of thousands of records every second. So if every second or every 2 seconds that someone creates a data or updates existing data, we lose a few milliseconds for a SQL server to recalculate the index and save it back to disk, well, we can live with that. That's the benefit that we'll get, right? In our case, getting search results for the biggest database, for the biggest client that we have, it was taking 10 seconds just to show the search page. Nobody's going to wait for that. Imagine if you go to Google and enter the query and just press search and wait for 10 seconds. I don't know whether they would make billions of dollars. Probably not. Now it's 1 second. Well, so 1 second is a conservative number. It's probably way lower than 1 second, but sometimes, depending on the query, it can get a bit higher, right? So it's around 1 second. And that's all thanks to 3 index views that took out 6 out of 9 joins from the query. Those joins are still done from time to time, but they are saved to the disk. We don't have to re-evaluate them every single time. And I would call going from 10 seconds to 1 second a success. Well, so it was in our case. The client is super happy about it. They are still paying us money, so that's success. And a bunch of smaller tips in the end. So dictionaries. Everybody knows dictionaries. Everybody knows how they work. They are fast. They are better than going through the list. And then everybody does linked queries all over the place, right? So you always like, well, I just want this record with this ID from this list of 10,000 items. And I want to do it in a loop 10,000 times. And it's fun until you get 10,000 users doing the same operation at the same time, and everything starts to get sluggish. So dictionaries are sometimes an option. So it's sometimes cheaper to just convert all the data you have into the dictionary with index on the thing that you want to look for, and then just ask the dictionary because it's going to be super fast. The query complexity for this thing is probably a log of n or whatever. For dictionary, it's O of 1, so it's pretty much a constant operation. It doesn't matter whether you're asking for a first record or the last one or the one in the middle or whatever. It's going to take the same amount of time, small amount of time. Sometimes removing functionality is a way to go. So if the client comes in and complains, well, this functionality is slow, sometimes it is an option to ask them, do you really use it, or is it slow when you are testing it and then nobody uses it? In our case, nobody was using some of the functionalities that were slow, so we just removed them. we told the client, but they never told, I assume they never told the users, and the users didn't notice because they weren't using it. That saved time, right? Well, that saved time. Well, it didn't make application better. It just removed functionality from the application. So we don't have to maintain this functionality in the future. We don't have to improve the functionality, and that saves money. And when something saves money, clients are happy. Load only the data you need, that's an obvious one, but people forget that with Entity Framework, with Hibernate, with whatever ORM you are using, it's super easy to just ask for the whole record and just use the name value, or just the ID because you just need the, well, maybe not the ID, but you just need one of the values of the record, or two maybe, right? So there is an option to load just the data you need, because if you have this big, huge record that weighs, I don't know, 10 kilobytes, maybe you're asking for 10,000 of them, it will take time for SQL Server to build the data and to send it over. Because on your local dev machine, the SQL Server sits right next to your application in the RAM. In reality, it's going to be across some kind of, I don't know, next room maybe? Maybe it's in the cloud, and that's far away, right? So load just the data you need. Cache stuff, if you need, right? So we started using, at some point, Redis as a cache. We started using Redis just because we have load balancing and we need the cache to be accurate across all the instances and everything, blah, blah, blah. Maybe you don't need to, maybe in-memory cache is good for you, but some queries don't change at all. Some values change so infrequently that sometimes serving the stale data is an option, right? So who cares if users see, I don't know, the old CSS values, right? Nobody cares about that in the front end, as long as they get refreshed in a reasonable amount of time, right? So how long does it get for CSS to get refreshed? I don't know, an hour, 2 hours, and that's okay, right? So for the data, it's probably not going to be 2 hours. Maybe that's going to be 5 minutes. But for 10,000 users asking for the data constantly, if you can cache it for an hour or 10 minutes even, that's going to make a huge difference on your database loads. And if your database load is low, then your other queries can use those resources and run faster, right? So did you expect some code optimizations? Sorry, not this time. Most of the problems and most of the applications I've seen are not related to the code at all. Well, not related to the algorithm you pick, right? It's not just because we run fancy graph algorithms that find the shortest path. Nobody does that. Well, nobody in the real business, right? Some companies do that. If you do that, good for you. I applaud you. That's super fun because everybody who went to university and started learning coding wants to do that, but nobody does. Well, most of the time. So we still write prod application, but yeah, so I just created all those points because I could. Yeah, and that's pretty much it. So in summary, test with appropriate data, measure stuff, because if you think that you are fast, probably aren't. If you measure and you know that you are fast, then you know it. Don't ignore the database just because you can have ORM. Indexes can be super helpful. Some other features of the database can be super helpful. Different levels of indexes and all. It's not just indexes. You can structure the database differently. The way, if people are using this plain old CLR objects approach, model first, whatever, code first, right? Sometimes the database structure is not the perfect one, is not the one you would like to have. Sometimes you want to split the data, sometimes you just want to merge the data, sometimes this super optimized database structure is not an option, you just want duplication of data because it makes it faster to access. So be aware of it. You don't have to be SQL Server experts, you just need to know a little bit about it to make sure that you use it when it's needed. Don't forget about front-end performance. Just the fact that you have fast laptop doesn't mean that everybody does. People use cell phones. I have shitty cell phones, so I know pages are super slow on the internet because my cell phone can't render all the React and Angular or whatever framework people are using these days. So also check that. Make sure, if you can gather numbers from the actual users. If you can't, don't, but check from time to time on your cell phone or get your mother or father's cell phone and use them because those are probably going to be slower, right? That's pretty much it from me. That didn't take too much time, I guess.
No, it's okay.
Just a few minutes maybe. If anyone has any questions, now is the time to ask them because I didn't do the Q&A. I can do the Hey. Yeah.
Do you use story procedures in your work?
Yes, we do. Not for all the code. So many of the queries we do are not so slow that we need to go to. Well, in stored procedures, you can write a SQL query as good as you can, right? And that's a good thing. It just gets harder when you need to update it, modify it, or whatever. You need to have appropriate deployment. And it gets easy for the client's database administrator to have an idea, oh, I will change the query for you guys. And that doesn't end well. Well, it happens sometimes for us. So we like linked queries more because they are easier to maintain, right? So unless we feel that there is a problem with that, we don't go to stored procedures. But the security part, for example, that I was talking about, that's stored procedure. That's actually a table value function, but yeah, same thing, right? So we use those, but we don't use those for everything because it's just easier with link.
Because I have a big experience with SQL Server and C#, and I saw a very big difference between entity framework and story procedures.
Yeah,
And if we have a very big project, for after some time we will have performance liquor degradation for entity framework.
yeah, that's definitely something that can happen. That's definitely something that did happen to us, but we are trying to catch those cases early on, and then we move over to either we rewrite those queries and we use SQL Profiler to make sure that the query structure is. Yeah, I know that Linker has its own problems, right? So it lists all the columns. It's sometimes hard to see if the actual query is complex or not, but we are looking at the execution plans. We are checking that to make sure that we avoid those problems. But if we have those problems, or if we feel that we can have the problems like that in the query, because we are writing big reporting query, we are using stored procedures and stuff to generate the data. Yeah, that's definitely an option and definitely the way to go in those cases.
Do you use entity framework core or entity framework?
No, we use regular one because, well, we are using regular .NET framework. We started with Entity Framework 6 and we are the latest version right now. The Entity Framework core will share a bit of problems with the full framework, and it's at the moment it's not mature enough for us to switch over. Well, and we use the full framework, so we definitely will consider it when writing new services. Then we'll probably consider using EF Core or something different, maybe Dapper, because why not?
Dapper is the best framework, Dapper.
Yeah.
Because I compared Entity Framework and Dapper, but if we will add extra features in Dapper, we will have performance degradation too.
Yeah.
And I decided to use Entity Framework because if we disable lazy loading, tree of changes,
detecting changes.
we will have the same performance.
Yeah.
And the new Entity Framework core, for my opinion, is more slowly now than
probably.
all.
Because they are still they threw away everything they had and they started from scratch, right? So they still get those performance degradations, then they get performance back, and then they will degrade and get it back. But I do believe that they will get some kind of decent performance out of Entity Framework Core, and it will be a decent choice for many applications. Don't know if most, but definitely for many applications. But it's definitely good to know there are other options, like just using the database, or using Dapper, or disabling those lazy loading, or everything else, right? So yeah, well, the lesson here is probably know the things you use and know how to use them and when to use them and when not. Yeah, very good.
Okay.
Did you have some plan how to search this performance issue, or you use some automation tools which scanned your system, or you just go where customer was complaining and then
Yeah.
look at there, just
So
like for pointing, yeah?
Yeah, so we use the customer complaint driven development. So customers complain that this part is slow. Well, this happened because for a long time we were having live customers, but those were low usage, low data volume systems. And then huge customer came in, and then all the problems flooded in, right? We did have some automation, unfortunately not around the parts that turned out to be slow, because those were the parts that were most of the time more hidden, right? So the search pages, right, those were the obvious ones, and the blame is on us. We didn't use the actual live data or the volume of live data. I take the blame, that's my fault. But most of the other functionalities were some kind of business report that doesn't get run too often, so we didn't bother automated testing its performance, right? So we didn't notice the degradation over time or stuff like that.
Did you look for something about after this for some systems that will emulate this live data or something like that to prevent this in the
We
future?
are in progress of doing that, so we will probably be using anonymized live data or something like that for testing. We are in the process of configuring all that and just making sure that everything
You're
works.
making your own tool, or there are some services that we can
No,
use?
so for the live data, we will probably, I think we'll develop our own tool, yeah? So that's probably going to be a bunch of SQL scripts that will anonymize the data and just copy database over to us. So we use some simple scripts for that and shared drives and stuff like that. We just get the data back. We use JMeter for performance testing. Probably right now we would use Gatling, it's called, right? In Gatling you can write code that queries test performance of your application more or less. There is a Java version as well, but we are a .NET group, so who cares about Java? So we would probably use Gatling, and there is an option we will use Gatling. We haven't made decisions yet, right? So right now we are using JMeter, and we will be probably adding some more advanced scenarios if we need to. We are gathering live data to some extent and just storing it in, it's called, I don't know how it's called, it's Grafana DB or whatever. We are storing it in this database, and we are plotting the performance live in Grafana, so we are from time to time having a look at that, and right now everything is good. Hopefully. So I haven't been in the office today, so who knows what happened. That's the way we do things right now. This is not the perfect approach, right? So as every project, we have always too few people. We always could use, have 10 more people and just have 5 of them test performance and write performance testing scripts and everything and check the data and yeah, that's fine until you have to pay those 10 people and you have the fixed amount of budget and you need to do with it, right? So those are cons that you sometimes have to cut, right? I imagine every project has those problems. Every project manager would say, yeah, I would love to have 10 more developers to make sure that the application is perfectly tested and perfectly automated and performance is good all the time. Most of the time we can't afford it, and it's simple as that, right? Until the problems arise, and then the clients decide that, well, all right, it's time to invest some money into it, and we did, right? But it's a slow process. It's not like throw away everything and concentrate on performance and just performance right now, because we still need to deliver features.
Do you practice data denormalization?
To some extent, yeah. Not too much, because most of the time we can just write better queries and throw a few indexes here and there and and everything works fine. But data denormalization is an option, right? So like I said, with this model code first approach, right? So it creates denormalized structure, but sometimes you want to have it creates normalized structure, and sometimes you want to do denormalization, sometimes you want to have the data duplication. You need to handle that, but that's the price you need to pay for getting better performance, right?
Have you tried event sourcing? Well, materialized view is some kind of...
well, no, not really. So materialized views and event sourcing are not related all that much, at least from my perspective. We didn't, because we don't have an infrastructure for that. We already have existing data for the clients. We couldn't just do event sourcing. We are thinking about event sourcing and common query request, the SQL REST, right? So we are thinking about it for the new project that's related to the current project, but that's going to be something new. We're probably going to go all crazy about it and use all the newest tools and whatever. We know that we screwed up in the last project, we're going to screw it up but differently in the new one, because that's always how it ends up. My English is getting worse with every single sentence.
You need a beer.
Yeah, definitely. So yeah, we would think about it. For most projects, that's not an option, right? So you have legacy data that you need to support. You just can't convert the existing data into event sourcing. The event sourcing systems are going to be much more complicated, despite what everyone says. Everyone says, yeah, event sourcing is simple, just do this, and no, it's not going to work. It's going to be complicated, because it's a complicated approach for huge systems. It's not necessarily the correct approach for every single system that you do. It's not necessarily the fastest approach, because if you do event sourcing bad, SQL Server with few indexes will be faster. But everything has benefits and the things that are not benefits. Like I said, every single sentence in my English is getting worse. I'm just going to switch to Polish at some point. I don't know how many of you will understand me. Yeah.
Did you use some NoSQL database?
No, we are well. We did use Redis as a cache engine, which is NoSQL database, which I can say now I'm a NoSQL database expert, I guess. No, most of the time we use SQL Server, because that's the thing we know. Again, in the new project, we are thinking about using different databases because it makes sense for those approaches. So, in general, if I approach a new project, I will consider SQL Server or some other SQL, Postgres, MySQL, probably not Oracle. I will consider those databases as my primary database, right? Unless I can see the NoSQL database is a right option, right? For whatever reasons that's going to be, right? So just going straight to Mongo because, well, yeah, it's Mongo and it's cool. Sometimes it is, sometimes it's not, right? So and for the new project, we are seriously considering that, but it's just too early to tell what we will use because we are super early stage.
Some more
I guess that's
questions? No?
Feel free. Well, we have a few more minutes if you want.
Some more questions?
Have you ever used search engines instead of Redis or something like this?
No.
Full text search.
Sorry?
Full text search for
No, so I tried full text. First of all, full text didn't return the data the clients wanted because they do things a bit differently. Search engines, we use Kibana for searching through logs, and that's the extent of using search optimized things in our project. Yeah, so again, if all the problems that we had were because we were fools and not because SQL Server is slow, right? So I know that this is common approach between developers that, well, SQL databases are slow. No, they are not. They are super fast. Sometimes search engines are the way to go, definitely, but just, again, like with document or graph databases, just make sure that it's the case that you want to solve, right? We didn't have that case, unfortunately. I would love to have fun with those. No cookie for me. Anyone else? Maybe something from the back, I don't know, there are a bunch of people out there. Nobody asking any questions.
No question? Okay. Thank you so much for your speech.
Thank
Small
you.
present for you.